Hello everyone. In today's sessions we're going to talk about different ways to optimize modern SharePoint pages or team applications that are using custom SharePoint Framework applications. My name is Velin Georgiev and I'm software architect. What I do in my business is that I'm consultant between the business and the development teams, where I identify requirements and I try to translate those requirements from the business to the development team so everyone can understand each other. I'm a Microsoft MVP. I'm part of the PnP core team and also certified Azure Solutions Architect. Anything else is that I'm trying to create my own tiny company called icewolf.ie, and I wanted to put it here just to get some additional exposure. Today's agenda is around mix of a real customer case combined with some demos that are not customer case because I cannot expose that data there. And we'll talk about different ways to analyze a page performance, page that has custom SharePoint Framework web parts or app customizers. And also then we'll dig deeper into how to reduce the size of packages, different ways to cache data on the browser, how you can move logic from the client to the server, and also very important part is how you can change the way you work so up front you can bring a better performance and better experience to your custom applications. Why would we do that? Why would we improve the performance? Well, it's quite easy. Nowadays customers or users expect fast page load. And because they're using public websites like Amazon, like Google, like the sites of Microsoft, they're used to see a fast load times. And if the page loads slower, it's less likely to be attractive for those users. And they're the same users in the corporate world. The same employees are used to that approach. And according to Google, 47% of the customers expect your page to be fast enough. Now, this is a real customer case that I've been working for the past few months. And the intranet page is being hit between 2 and 2.5 million per month. That means that it's between mid-size and big-size organization. And it's a SharePoint page. And before we started optimizing, the page was loading in these time frames. It was loading on average around 70 seconds. And we've put a threshold. We said that we need 6 seconds. Everything above 6 seconds is not normal for us because it's too slow. And this is the breaking point here after our POCs. You can see that the page loaded in 4.5 seconds. And afterwards, we've got a good success with the following POCs, where at times the page were 4.3 seconds. You might say it's still slow. Why 4 seconds? And this is a good question. It could be 4 seconds because of various reasons, especially inside corporate organizations. And many of those reasons might not be the developers or the custom application itself. It could be the corporate proxy intercepting and slowing down the network. It could be too many policies slowing down the hardware. It could be the hardware itself because the developers are used to work with modern hardware, modern machines, but the average accountant might be using a machine that is 10 years old and it might not keep up in the processing of too much JavaScript, for example. Could be a poor VPN or someone working from a remote connection. Recently we had a case where a lady was working from a rural place where the download speed was 30K per second and she was complaining because the site is slow. But this affects the analytics. This affects the metrics. So that's why And of course, because of all these reasons, the corporate employees will have a some tolerance, and they would not expect below 2 seconds, probably. Now, another good reason is your custom application. Your custom application might be having a blocking code that is slowing down the page, but you might not know it. And it might be done by a junior developer or someone else, and we have to investigate. And we can actually investigate there. We cannot solve the corporate proxy as a developers, but we can solve, we can do some optimizations on the custom applications themselves. A little bit about the home page. It is a communication site. It is using a modern page, but it has 34 custom features. So the whole page is built around custom web parts and app customizers. There isn't a single out-of-the-box web part. And it's pulling data from Azure, it's pulling data from internal systems. This is how it looks. It has customizer on top, that is a navigation, but it has much more functionality that you're seeing here. And we'll talk about that later. It has a carousel looking web part that is showing news. And then it has another one that is showing users business unit news. That means a personalized content. It has another one that's showing user subscriptions. That it means even more personalized content when the user has saved something in their user profiles or in Cosmos DB, and we have to serve it from here. And then there are the company events, and then there is the footer. So nothing really fancy here, but all these different web parts are highly customized, and you might have pinning in the front, which is additional logic. You have rules for localization. That means if the user is in a different location, a different type of news has to be pulled. And rules for if the user belongs to a business unit or a different segment, different rules apply. So there is a lot of logic happening here, highly personalized page, and we had to analyze it and see how we can improve it because it was loading slow. And this is the process we've taken. We had to do our analysis first, and then we had to identify areas of improvements, make some proof of concepts, and then see if that is going to work. Now, there is the first thing, analyze. So one way to analyze your page performance is simply by opening a developer tools on any Chromium browser, like Edge, and see what is there. Let me try to demo that. I have a SharePoint page here with a custom web part over here. I will hit F12. This is the new Edge browser, or you can go from, I suppose, here somewhere, more tools, developer tools, or just F12. And the developer tools will open. They have different tabs here, but there is one that I'm interested, and you would be interested, and it's called the performance one, the performance tab. And here there is an instruction to say if you want to reload that page, click Control Shift and E. And this is exactly what I'm going to do. Control Shift and E. And it's doing some profiling, and then it will give us a nice screen with different information that we can look at and see if we can quickly find out something from here. So this is the top timeline where we can control, and we can select different timelines. You can see that the whole page loaded in 4.6 seconds or something like that. And here is the network. So the network is really important. And then we'll have a look at the main JavaScript thread. These are the two things I usually look at, and I don't look at the rest of these tracks here. So we'll keep it simple, and we'll try to explain the network first. And as on the network, you can see that this is the server, and the server responded in that time. And then it's starting to download different things. And there is a lot of happening in a SharePoint page. I will just select the whole timeline, and we can see that there is a lot happening. There is a lot of things here happening. And we have a pages assembly that is taking SP pages assembly that is taking a fair amount of time loading. But we also have our Hello World web part that is taking even more. And the criteria here is these are loading in parallel. And if your web part is loading more than the pages assembly, and the pages assembly is a fairly big file, then you have an issue. This is my criteria. This web part is loading in 700 milliseconds, which is not acceptable because it's blocking from that time here to that time here, it's blocking. That is like 300 milliseconds, it's blocking, and your browser is not doing anything. And this is scary. And we have to take a look at the web part and see why it's so big and why it's loading so slow. One way to do that is to use, where is it? Yeah, it's to use the Webpack bundle analyzer. And it will show you what you have in your bundle. I've added some useful links here, but I use the PnP SPFX generator because when I create a new web part, the bundle analyzer is coming with the options there, and I don't have to do anything than just to start using it. And I have one web part over here, and then I'll try to investigate what's going on. This is my web part, and because I scaffolded it with the analyzer, I have a handy option here that it's saying analyze. Okay. That will generate an HTML file with all the dependencies in my solution, and I will explore what's happening and why that file is a potential threat to my performance. So this will done here, and it will generate a file. Now, because I'm using the command line, I have typed just explorer dot to take me to the solution folder. And here under temp, we have stats because the stats are being generated. So if I click on that HTML file, I will see all the dependencies inside my GS web part, and you can see that the file is 3.82 megabytes. Which is even a gzip size will be 1 megabyte, which is not quite acceptable because it will take a long time, especially if you're on mobile or remote space. And I'm sure we can get rid of some of those modules here because, as you can see, we've bundled the whole Fluent UI and the whole Material UI, and perhaps we don't need the full libraries. If I go to my code, I'll have to take a look and see what I'm actually using. My code is using my one button from Material and one button from Fluent. So perhaps I don't need all these libraries. I need just the buttons that are here from the libraries. And probably I'm using the wrong import mechanism. I'm importing the whole Fluent library, and this is the don'ts and the syntax that we shouldn't be using, and these are the do's and the syntax that you should be using. Now, both of these should work, and these will include the whole library, which will add additional load on your page. And imagine if you're using multiple libraries, then that file will grow enormously big. So I'll comment out those, and I'll leave just the top one to show you how we will reduce the bundle. And I'll comment out this button as well. Now I will rebuild, or I don't even have to rebuild. I will just analyze the solution again, and we'll see if that has reduced the size of it. It's 3 megabytes, nearly 4 megabytes. I reload, and now we have 360 kilobytes, which is a huge saving. and I'm including only just button related stuff here. I'm not seeing any more lists and the full library. Another way to improve performance and experience is by caching some stuff on the browser. And there are different ways to cache on the browser. What do I mean? Here is our scenario. And our scenario was very simple. We had to load content based on user profile data. But before we load the content, we have to get the user profile data. So we had to go to the user profiles using the user profile service, grab the data, and after we have all of that data, make decisions and based on those decisions, fetch data or fetch the content. That could be news articles or list items or whatever. For that time of 200 or 300 milliseconds, we cannot do anything because we are waiting to get the user data. And that means that we are delaying the content with additional 200 milliseconds. To avoid that, we can use the browser cache. So how does it work? Browser has some storage mechanisms, and the first time when the users access the browsers, we will have to do those 2 milliseconds delay to get the user profile data. But once we do it, we can store it on the browser, within the browser storage. And then next time when the user visits the page, instead of 200 milliseconds delay, we'll get a 2 milliseconds delay and we can process the content faster. Different mechanisms are there, and we have session storage, local storage, IndexedDB, and WebDB, and most of those are supported by all the browsers. Okay, how can you find these storage mechanisms? Well, they're in your browser, and if we use the developer tools again, and if we go to the application tab, you will see on the left all these storage options here. And as you can see, even Microsoft is storing data there, just to serve it faster than making a web request. I will do a quick demo where I'll show you how I've stored that data into my session storage display name, and we can see how we can do it from the code. So display name is stored here, and displayed below, and it's connecting the user profiles APIs. So it's a basic fetch query here that is saying get user profile, and I've collapsed those because we don't need to look at those at the moment, and it's just doing a query against the user profile service, and it's getting the user profile display name here, and it's displaying it within the web part. But there is no caching at all at the moment. It's just a plain web request every time when you open the page. The way to do it with cache is adding a little bit more code. So here we have get user profile, which is just a REST call. And here I've changed it where we've renamed that function from user profile to user profile server. And it's pretty much the same with one difference. And our current get user profile now is slightly different. It says session storage get item display name. That means that if the item is within the storage, the browser storage, we will use it instead of going to the server. But if it's not there, if it's null, we'll still execute the server call. And finally, when we get the data here, we will store it into the local storage. So as you can see, it's simple, few lines here and down there. The way we get items from the session store is just get item, the key. And here it's just set item, the key, and the value has to be string. The next way to improve your app is to move some logic from the client to the server. And this is maybe where the biggest improvement will come if you have really customized pages. And let me show you what I mean. This is what we had. We had 8 web requests for the navigation 34, that web part 4424. In general, we had 23 web requests. And these web requests have to come back and pre-process the data. That means that you're merging data on the client, and you might have a big data sets that have to be merged. Then the client will have to do all that on the CPU of the user. And sometimes it's really, really slow, especially with hardware that's not prepared for that. Now we reduced 20 requests from 23 by moving them to a web job. So what we were doing is, instead of loading all these search API queries against SharePoint Search on the browser while the user is waiting, we moved them in a web job, or this can be done in an Azure function. It's a little bit extreme, but it works. Every 9 minutes we update the content, and this content is not mission critical, so we can afford making it a little bit offline with 10 minutes delay. Every 9 minutes we execute those 20 web requests on a web job in Azure. We do the data merge there, and then we move the data that's been organized in a way so we can quickly render it to SharePoint, again, into a document library. Could be the SharePoint CDN, but the CDN cache is 1 hour, so people will experience delays. What we do is we just move it there in a document library, and we fetch that JSON file from there, from our web part. That data is 49 KB, and it's loaded really, really quickly on the page, and it's organized in a way that the time for rendering it's fast. That means it's organized in a dictionaries where you don't waste time in for each loops to find out the data, and you just render it. So it's another way to aggregate the data through a web job, and this is where we gained most, because it was highly customized, simply. And in a cases where you can't use anything other than SharePoint, we still have to minimize the work there by minimizing the queries we execute. Also try to reduce as much as we can the expensive methods within our business logic that's executed on the client. One way to have a look at your expensive methods in JavaScript is, I'll go back to that page again. I'll open the developer tools here just to show you how you can easily find functions that are really expensive and they might impact the performance. And down below we have that summary bar, but also we have bottom-ups. The way I usually track the methods that don't behave within my code is when I sort by self-time. And I purposely did that here, and in self-time there is something that executes for more than 2 seconds. And it's a T component will mount, and it is inside a Hello World web part GS. Okay, the more of your web parts you are seeing here on top, the better the situation is. So bear in mind, if you see on top more of SP Pages assembly, now that means you're in a good situation. If you see more of your web parts here, very bad. And let's go into that and see why. I'll just jump to my code and I'll go to component will mount here, and I'll show you what I did. Where is it? Here. And in a component will mount, I just said block for 10,000 iterations. Okay, let's go back to here. There is the next one. Over the course of 3 years, we identified a few interesting things in our process that helped improving the overall quality of the applications, that means the overall user experience. 3 years ago, when I started with working with that team, we've created a simple manifest. And then lately we've started using pull requests, where we were demanding on those pull requests to be more often small. And then we've elected some seniors to review the pull requests, and they had to review them closely and help the other users to provide a better code base. And then we've included unit tests, and it proved that the unit tests are forcing specific roles on the developers, and they don't blow up the code because they have to catch up on coverage. So they try to reduce the amount of code and the amount of unnecessary functions and actions that are being there just to meet the unit test coverage, which proved to be a really good move. And then we started using a DevOps pipeline, where we were checking for failures, and this basically will fail tests. Then it's not necessary for anyone to review it and to waste time until those tests are fixed. And then we somehow managed to work with vendors, where the vendors were supposed to bring their code to our source code repositories, where we could check them, and they had to follow the same process as follow the manifest, create pull requests, etc., etc. Very, very good example of that way of working is the Office 365 CLI. Now just go there very quickly to show you. The Office 365 CLI has a really, really small manifest that everyone should follow, but that greatly improves the way something is being submitted, a piece of code is being submitted. Everyone should follow that. And then the pull request itself contains just the fair amount of code that's supposed to be here for every command, and it passes check on a automated pipeline. And if you don't pass that check, no one will bother reviewing that. So it's like another quality gate. And down below there is a detailed review of what we are supposed to do, and it's really, really nice, explained by whoever is doing the review. And then the developer will have to do those necessary fixes. So in general, this is improving the quality, and we saw that with the Office 365 CLI. I also saw that on my current role, where I'm working with different teams in that comparison. So it is of a great benefit. Don't underestimate that, and don't let vendors deliver code after 6 months and you have no idea what is in that package. These are some interesting things that we did over the years. And first one is we were using AWS in that scenario with the Intranet homepage. We removed the AWS and we started using the out-of-the-box features of the SharePoint Framework that has built-in mechanism to connect to third-party APIs. And that improved as well the page load times, because we didn't have to load that as an external dependency anymore. External dependencies in the SharePoint Framework is something you should have a look at and try to reduce down to a minimum, because it's additional files that the page has to download before your apps are visible. Then use your own CDN if possible, because the Office 365 CDN cache is 1 hour. And there are definitely files that we could cache for more than 1 hour. Then decommission Internet Explorer. I won't even talk about that. If your organization is using it, just do it. If you're using long or short polling mechanisms in your JavaScript to poll API, that could also destroy the page performance. Please avoid those. And I wrote a blog post maybe 2 years ago, and it's still relevant. You can visit it if you'd like. With that, there is a quick link for feedback. please leave your feedback there, because this will improve our service and it will improve your experience. And thanks for being part of that session. I hope that you've learned something new, and bye.